Hello students, welcome to Dr. Shoraph's classes. So in this particular video, we'll be solving problem for the advanced placement calculus AB, and we are solving this question of the subjective type, that is the FRQ, that is the free response questions. So those who have undertaking this course in advanced placement, they know this FRQ is quite challenging and it carries one of the most significant part in improvement of your overall score. If you want to improve your overall score, then we are following a 5-point strategy. So this 5-point strategy is just, we'll mention the 5 points, but to work on it you have to do a lot of practice. So the point number 1, read each question carefully. Point number 2, you have to maximize your points on the multiple part question. Point number 3, you have to share your thought process. What is your approach for in solving this problem? Point number 4 is your clarity and consciousness, how much you're clear and conscious about the problem, how to solve the problem. And point 5 is the proper usage of penmanship. So this 5-point strategy, if you follow, and along with this you need to do a lot of practice to gain this particular skills in this clarity and consciousness, and where to share your thought process. So this thing's a lot of practice. So with this, if you combine these things along with your practice, so it will be easy for you to get a marks on the high end for this particular section of FRQ. So let us move to the question 4. So here you see there is a question from part B, and here you have the graphing calculator is not allowed to solve this question. So here you can see the cylindrical barrel with 2 feet of diameter of 2 feet contains collected rainwater as shown in the figure above. The water drain out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to the time t is modeled by dh dt minus 1 by 10, this minus 10, 1 by 10 root over h, where h is measured in feet and t is measured in seconds. So the volume V of a cylinder with radius r and height h is we know that is pi r square h. So let's see what is the first question. It's saying that part A is asking find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. Indicates units of measure. Okay, so this V we know that is pi r square h, it is given. So r is 1, so pi 1 square h, it is simply pi h, right? So the volume dv dt at h equal to 4, it will be pi dh dt at h equal to 4. So we have this pi minus 1 by 10 root over 4, which is simply minus pi by 5 cubic feet per second. So that is the answer to the question part A. You have to find the volume and we have to indicate the units of measure. Okay, that is the cubic feet per second. So we can write it in a more, okay, so we can, this is equal minus pi by 5 cubic feet per second. Okay, that's all. So that is your answer for part A. Next, part B, let's see. So when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. Okay, so this part B. So we have this d2h dt2 is equal to minus 1 by 20 root h dh dt, it is equal to, so if you solve this it will be minus 1 by 20 root h, dh dt is minus 1 by 10 root h. So it is simply this 200, this 1 by 200, this root h will cancel out and the minus minus will get plus, so 1 by 200. So now, because you can see that as the d2h dt square is equal to 1 by 200, which is greater than 0 for h greater than 0, so the rate of change of the height, the rate of change of the height is increasing when the height of the water is 3 feet. So that we are fine. The height is increasing. The rate of change of height is increasing. Okay. Yes. So to find whether it is increasing or decreasing, so our answer is increasing, along with the we are given the justification, explanation. So now, so this part C, so it's saying that at time t equal to 0 seconds, the height of the water is 5 feet, right? So use the separation of variables to find an expression for h in terms of t. We have to find an expression for h in terms of t. Okay. So let's solve this part C. So part C, we have this dh by root over h is equal to minus 1 by 10, it is dt. Okay. So if we do the integration on both sides, so integral dh by root over h, and it is minus 1 by 10 dt. So it will be simply 2 root h minus 1 by 10 t plus c. Simple. So h is 5 feet. Okay. So 2 root 5. Okay. So minus, it is 0 at time t0, so it will be plus c. So from here we can find what is c. C is nothing but 2 root 5. Okay. So now putting the value of c over here, so we have this 2 root h equal to minus 1 by 10 t plus 2 root 5. Okay. So from here if you solve ht, it will be coming as minus 1 by 20 t plus root 5 whole square. Okay. So that will be the expression for h in terms of t. So that's all for part C. Now C, let us see how to check the point distribution, that is scoring points or getting the part for question 4a. So this dvdt will fetch you 1 point, and the answer with units, this fetch you 1 point, so 2 points. Next, in the part B, so for the first part we will get this 0.1 dh dt. So this 0.1 plus 0.1 for the d2h dt2, and the explanation will fetch you another 0.1, so 3 points. And for part C, first of all, the separation of variables 0.1, the antiderivatives, so this is another point, to find the constant of integration, another point, and finally you have find the expression for ht, that will give you another point. So 4 points for part C, 3 points for part B, and 2 points for part A. So that's the question number 4.